Alright, so for the second reaction, for the second question, we are looking at this one where we have a sample of aluminum foil. So let's go through that again. Aluminum foil, where this is a reactant, it burns in bromine vapor, also a reactant, and it produces a sample of aluminum bromide and says solid aluminum bromide. Okay, so let's write down our word equation. So we have aluminum reacting with bromine and it produces aluminum bromide. Let me use the correct color and it produces aluminum bromide. Okay, as we are writing this, please also fill it up in your theory book. So let's convert this into chemical formula. First one, for aluminium, this is an element, but it is a metal. For metals, can you please remember that for the formula of metals, it will just be the chemical symbol. Okay, so for aluminium, it is just Al. Okay, for bromine, if you remember in your periodic table just now, we circled the diatomic molecules. Bromine is over here, right? This is bromine over here, so it's diatomic, which is why this will be Br2, diatomic. Okay, and we will get aluminum bromide. For aluminum bromide, please recognize that it is a metal and a non-metal. That's why it is an ionic compound. So let's look at the charges of each of the ions. For aluminium, it is Al3 plus because it is in group 3. So you can see from the periodic table that aluminium is here, group 3, that's why it has a charge of 3 plus. Okay, and for bromine, it is in group 7. So bromide is an ion of bromine. Bromine is in group 7. That's why it has a charge of minus because 7 valence electrons. It just needs to take in one more electron to form the noble gas configuration. Hence, having one more electron, that's why the charge is negative. Okay, and this will be Br minus. So when you look at the charge and you crisscross, what you will get is 3, bring it across, and then here is 1 actually, you bring it across, right? Our formula of aluminum bromide is AlBr3. Okay, so let's balance. For aluminium, if you look at the cursor here, aluminium is one, there's one aluminium here, and there's one aluminium here. So aluminium is not really an issue. But for bromine, there's 3 bromine here. However, there's 2 bromine at the reactant site. The lowest common multiple between 2 and 3 should be 6, right? So how can I get 6 bromine? To get 6 bromine, I will need to introduce 2 aluminum bromide, and I will need to introduce it to have 3 bromine molecules. So you can double check again. Let us double check. I have Al and I have Br for the reactant, and I have Al and Br for the reactant. So in this case, I have 3 times of 2 bromine, so I've got 6 here. I've also got 2 times of 3 bromine, so I've got 6. There's 2 of the entire set of AlBr3, right? Okay, sorry. So this should be Al, right? So as mentioned, there should be 2 of AlBr3, so there's 2 Al here, right? But you notice at the Al for the reactant side, there's only 1. So I will need to make sure that I have 2 of them by writing a 2 next to Al. Okay, hence balancing up with 2 Al and 6 Br on both sides of the equation. So what is going to be the final one with state symbols? You will notice that for the in the text, we have a sample of aluminum foil. You have worked with aluminum foil before and you will know that it is actually solid state, right? So I have Al, 2Al solid plus 3Br2 This is bromine vapor, right? Bromine vapor. So this should be gas, G, arrow, 2AlBr3. This is mentioned to us that it is solid, right? So I should have it as AlBr3 bracket S. And that is how I form the balanced chemical equation of reaction 2.